Welcome to the second lab of Computer Networks Lab. So, we have started the circuit programming in C. My name is Salman and I'm the lecture assistant of this course. Uh, in this lab, we are going to study the protocols, the circuit creation, and the data transmission. So, let's start it. Before starting the lab, I have a review question for you. The sequence of the steps that I have written here: binding, circuit, listening, connect, and accept. Are they correct? Are they in the chronological order? Means that they are in the order that I had explained you previously. Do we need the binding first, circuit next, then listening, then we need connection, and then accept? So pause the video for 5 seconds and think about it. If you come up with the right answers, then just play the video and I will answer you the correct sequence in a while. After resuming your video, I will give you the correct answer. The first one step that we saw there was socket. First we created the socket. Then we bind the socket with a port number and IP address. After binding the socket with a port number, then the socket was ready to listen. And then any connection coming at that listening port was able to be accepted. And at the client side, when it wanted to make a connection with the server, it was making a connection request. And then the connection was established from the client to the server. So those are all the steps that we studied previously. And now let's move in more deep in details to see what the circuit exactly is. So previously we saw this picture. We saw the socket takes three arguments, and the three interesting arguments were domain, type, and protocol. But we didn't know the exact meaning of domain, type, and protocol. And this lab, I'm going to explain you what these three things are. And these three input arguments are taken by the socket, and it will return you with a file descriptor. The protocol. What is the protocol exactly? The protocol means any any policy or any rule or any kind of steps that make the communication to happen, that make the communication possible. For example, I think it's becoming more complicated to explain you like that, but just in simple words, in your home you have a tablet or you have a computer, and then your friend is living in the neighbor and he has also a tablet, and you want to communicate with each other. You want to send him email, or you want to send him a message on Facebook or any other social media, Instagram, or you just want to make a communication with him. Let's assume you don't have the internet. And have you ever thought of it? When you don't have the internet, why can't you make a connection? Why can't you stream the data? Have you ever thought of it? So that is the first thing. Why do we need the internet? And sometimes you may have seen that even though there is no internet, but you are sitting in a lab and you are still able to send the data from one computer to the other computer, or you have a shared drive in an environment. You can put your files in that drive, but when you leave that lab and you go to your home, you can not able to access that particular lab or that particular shared drive. If you want to send a data to your friend which is sitting in the other home or other building, you may need a computer, you may need a switch, you may need a router. But let's assume you have a switch, a router, and a computer. You simply plug everything through wires and you just provide the power supply to it, and still you want to make a connection without configuring them. Are you still able to send the data there? Of course, no. You are still not able to send the data there because you have to do some further protocols. You have to go through some other further steps. You need an IP address. Your friend need an IP address. Then who is going to provide you the IP address? Are you going to statically configure your computers with the IP address? or some there is some DHCP device which is providing you the IP address automatically. So that is another question. There can be some device which, when you turn on your device, when you turn on your tablet or computer, it will directly give an IP, give it to your device, and you are just connected like that. But if you don't have that kind of system, that kind of rule, then it means that you are not being given an IP. And if you are not being given an IP, then it means that you cannot send the data from your computer to the other, because you are unknown, you are invisible in the computer and in the internet. So the first thing you need is the IP address, and then how to establish the connection. What kind of connection do you can you establish? Is it a TCP or a UDP? Are you making reliable transportation of data, or you're not, you don't need it, you need a speed, and you can compromise even if some packets can be or lost. For example, you are playing games, so that is called UDP. So all these things coming into picture when you are able to send the data properly from your home to your friend computer sitting on another building or some other place, then it means that you followed all the protocols, all the procedure, all the policies, and those procedure and policies make your communication to happen. If you skip any of the policy that was making that communication, then you won't be able to send your data, or you won't be able to communicate, right? In simple words, both the parties can communicate with each other using the agreement terms and condition. If two persons want to talk to each other, they should understand each other language. If they have the communication barrier, one is speaking Dutch, for example, the other person is speaking English, then they don't understand, for example, each other language, then they won't be able to convey their idea or their information to each other. So to make this communication happen between them, it means that they should understand each other, and they should use, for example, a middle language, so that both of them can understand, and then using that middle language they can communicate, or they can talk. The network protocol are formal standard and policies comprised of rule, procedure, and formats that define communication between two or more devices over the network. It need to be specific to create a socket. It's like a detailed deal between the two people for co-working. So the deal means they should understand each other language. So for those people, the protocol will be different. So for different applications, you have different kind of protocols that you have to follow. And after following those protocols, you can transport your data from the source node to the destination node. The other important thing in the socket is the domain. What is domain? Domain means that what kind of IP version you are using. Are you using IP version 4, or are you using the IP version 6? There are two different family of IPs, either version 4 or IP version 6. The IP version 6 is the next generation of IP that is not completely implemented, but in some applications or some venues it has been implemented. IP version 4, it was invented in 70s, and it's still very popular. Every person is using it, but there is a limitation. The IP version 4 can support up to 4 billion of users. You have 4 devices, for example, and each devices you want to connect with the internet. It means that all of the devices should have the IP address, right? So a single person, for example, needs 4 IP addresses. And then if you have more devices, then you will need more to connect with computer, then you will need more IP addresses. And think about some big countries in the world, like China, for example. If every person owns 4 or 5 devices, and then they need the IP addresses, and take the population of the whole country, then it means that all the IP version 4 billion of the addresses will be consumed by that country. Then what will happen? So this kind of limitations, there are some more things like network address translation and some other thing come into picture, and then they are reusing the addresses, are doing some other stuff with the addresses, and they are still extending this 4 billion possible addresses to more addresses. But there is still this kind of limitation. The IP version 6, it has enormous amount of IPs, so you don't have to worry about the number of IP available. um, and it has also some other kind of benefits. It has more efficient routing, or it has like, routing, right? Routing means how to transport the data from one node to the other, and how to choose a best path for moving that data, and how to efficiently transmit the data through that best possible path. And then the it has also some efficient packet processing, and some good data flow mechanism. And overall, IP version 6, it is the advanced version, or it's the next generation of IP, and that can be used by the devices also. That can also be another option. So anyhow, let's come back to the domain. Whether you're using the IP version 4 or IP version 6, you have to define it in the domain. So there are two ways to do it. One is pfinet for IP version 4, and pfinet 6 for IP version 6. Or the other way is to use AFINet and AFINet 6. There is no much difference between the pfinet and AFINet. Even if some programs you put the pfinet, it will be translated to the AFINet. So you can use either of the convention, pfinet or pfinet 6, or AFINet and AFINet 6. So in domain, basically the main goal is to just define that what version of IP you are using. And the third one is the socket type. So what kind of socket you are going to use? There are like raw socket or sequence packet socket, so we don't have to worry about these guys. The most important and the most popular sockets are two types. They are TCP or UDP. TCP, almost 90% of the applications, are more than 90% of the applications are using the TCP, transmission control protocol, which obeys the two-way handshaking. What is the two-way handshaking? It means you are sending the data from source to destination with some sequence. And once the destination receives that particular sequence that it is expecting, it will acknowledge back to the sender that yes, I received that particular packet, and you can send more packets with more speed. Sending the packet from source to destination, and then the destination acknowledges back, and then again sending the data at much faster rate. It means it takes time, and then it will be not that much faster, right? So to send the data faster, there is another protocol which is called UDP, and it's mostly used for latency sensitive application. Latency sensitive application means you are playing a game. So when you are playing a game, you cannot tolerate any kind of delay, right? If you are, for example, playing a Counter Strike game, and there is some connection failure, or there is some the connection is very slow, then the opponent will shoot you, right? So for to avoid that, you need to have a reliable and fast connection, and before someone is shooting you, you should shoot that guy. So, sorry, I'm just talking about the Counter Strike game. Anyway, that kind of protocols, or that kind of application, they need a very fast application. So, in that cases, like voice applications or video live transmission applications sometimes, and also the gaming application, they're using the UDP because uh, they cannot tolerate any kind of delay or latency. So TCP is reliable transportation, and UDP, it's okay if some packets are dropped. And you may have experienced this thing whenever you're talking on a call on certain application. your call start breaking at the middle. When you are talking, the conversation sometimes drops, and you will miss some segment of your talking or conversation, and then it starts again. So that kind of dropping the audio streams, it basically happens just because the UDP, it doesn't care about any packet dropping. So some packets are dropped and you cannot hear those packets, and then in the next sequence or in the next stream you just listen to it. Here are two pictures. This guy in the right, on the right, he is packaging some packets and on the belt, and the conveyor belts is transporting these belts to the destination person, which is this person, and this person is checking the sequence of the packets coming from that guy. So if all the packets are coming in the correct sequence, he can increase the build speed, or he can just accept it. He will accept that it's fine, and he will acknowledge back that the last packet I received was packet number 3. And then when this packet received, this will say the last packet I received was packet number 4. Then when the last packet I received was packet number 5. So each time it is receiving a packet, it will check the sequence number, and once it's checked the sequence number, it will acknowledge back to this sender that I received that particular sequence number, and this transmission or this sender guy will then keep sending at more faster rates. So that since he knows that the packet the packet I'm sending here, it can they are receiving there. Maybe there is something happened that the packet become congested and they collide with each other, and some packet drops. Some packet drop from here. And the guy who was expecting some packet at a particular sequence number, he might not receive that particular packet. And he will acknowledge back that the last packet I received was packet number 15. Although this has sent a lot of more packets, so it means that this will come to know that my packets are dropped here. The last packet the acknowledgement for the packet I should have received should have been like packet number 25, but I received packet number 15, which means that some packets are missing. So he will resend from the 15th number packets, and he will slow down its transmission. He will slow down the sending packet rate, right? So this is for the TCP. Now let's take the example of UDP. These two guys, they are delivery people, and they are going to deliver the pizza, and they don't know how much there are a lot of pizza on the top of each other, and then they are moving. Maybe some of the packages will drop, but since they are moving at high speed, they are unaware of it, and they will reach to the destination, and they might not be able to deliver the pizza to some specific ordering places because those packets or those pizza were dropped on the way when they were reaching there. And this kind of conversation or in this kind of communication, even the packet drops, the sender is not acknowledged. He is not acknowledged with the packet dropped. He is not unaware of it, and he just keep transmitting it. So this is socket stream, and this is the socket datagram. I hope it's clearly understood. There are different types of protocol, um, and you can see it on your computer. If you want to check it, you can just go, for instance, let me show you. Uh, Let me maximize the window, and you can see like cat etc protocol. So you have like internet protocol, or you can have the transmission control protocol, UDP, which is 17. This is the user datagram protocol. So all these kind of protocol can be used, and depending upon your application, which protocol you are using, and for that one you can put it here, and you can make your own socket uh, based on that protocol. So please bear in mind, you have to choose the proper protocol for the type of application you are using. Okay, for socket creation, it's now quite clear. You need three things. The one is domain. Domain means what kind of internet IP you are using. Are you using IP version 4, or you are using the IP version 6? Depending upon your application, again, you have to choose properly and carefully the domain. Type. What is the type of the communication? So if you are using, for example, TCP stream, you have to use the SOC stream. Or if you have to use the UDP stream, then in that case you have to use the SOC DGRAM, which is called datagram. So either of the case can be used for different application, as I mentioned in my previous uh, slides, that uh, transportation, the TCP is always used for reliable transportation of data when you need to securely transport your data from the sender to the receiver. In that case, you will have to make the connection through the TCP. But if you don't have any issue with the reliable transportation, then you can use the UDP. In that case, it will give you high speed. So there is a trade-off: the speed versus reliability. If you need high speed, that means that you have to compromise on reliability, and in that case, you have to use the UDP. Otherwise, if you need more reliability, then you have to use the TCP. So you have to keep this thing in mind. And finally, the protocol. So in other case, for example, if you're using the SOC stream for TCP or the SOC DGRM datagram, so either of this one which you're using, you have to choose this one value as 0. But if you have to use some particular protocols, then you have to choose that particular value for that one. Now let's create our own socket. So far we are seeing that how the socket is created, how it is binded, then how it listens, and then how it accepts. We have two entities. One is our server and the other is a client. So there is a server and client relationship between the connection to establish. So the server takes server creates a socket first, then it binds at a port and IP address with the socket, then it listens, keep listening at that particular port, and if there is any connection request coming from the client through to that specific port, it is accepted. And the other one is the client uh, creates a socket, and then it sends a connection request to the server, and once the server accept the request, the connection is established, and then any data that is coming from the server, it is received by the client. So let's first create a file for the server, the C file for the server, and then we will execute it and then we will run it. So let's see it how it can be done on step by step. Okay, so I'll close it and let me open a notepad because it's easy to do the coding things here. And I'll make a new file, and firstly for I will just save it, and where I have to save it, you know it already, home. Then it will be definitely created at your name, and since we are using the server, so we will create a file server.c. So let me start with the server file first. I'll first add all the required header files. As you know, it's necessary for any C program. So I'll say hash include stdio.h, and then what else do I need? I should also put hash include, and I'll say studiolib.h. Then I need some socket header files, so I'll also add that one. Sys/socket dot h, and what else? Yeah, I need also hash include sys/types.h, and I'll need something for the internet IP address, so include, I will write netinet/in.h. I hope this will be fine. If I needed any additional header files, then I will include it later on. So my program will tell me if I need anything. Let me start with the main body of the program. So I will int main, and let me return 0 first because I may forget it later. So now, now I can start my program. First of all, we need a buffer that can keep our data. So for that, we will declare the buffer. Uh, let's say I'm calling it server underscore MESSAGE. I'm calling it server message, and let me keep the buffer size as 256 bits. I think it's in bytes, and I'm not sure whether it's bits or bytes. I'll check it later. And let me write it down like socket programming in C. So the server message buffer contain a message which is socket programming in C. So once we are testing it through the client should receive a message like server programming in C. Uh, I'll also put some comments while doing it so that you can understand all the steps very clearly. So now I'm creating the server socket. So to create any socket, what are the steps? I need to call this function, and then you have to first feed which one IP you are using. So I am preferring to use the IP version 4, and then I'm preferring to use sock stream, which is the TCP, and then by default I'm using the TCP protocol, so I'm not doing anything with that. And what else do we need? Can you see there is something? Oh, there, sorry, there I have put it wrong. This is SOCKET. Okay, yes. And here I have to identify the file descriptor, so I'll call it the socket, or I will call it server underscore socket, or you can declare it before int server socket and then just simply put server socket is equal to this thing. So that's up to you. That's just a basic C. Now my socket is created. Now I have to define the server address, right? So let me write down define the server address. For the server address, I'll just make it in the form of structure. Why? Because we need to put the port address, we need to put the IP address, and we also have to specify what kind of address we are using, IPv4 or IPv6. So with simple and integer declaration, it will not be possible. That's why we are making a struct. So struct, and I will say sock addr underscore in. I'm calling it sock n, and then server underscore address. So this is my structure created, and I will call the server underscore address every time dot what is sin underscore family. So which one version of TCP IP I'm using? So since I told you I'm using the AF underscore INET, right? So I'm using this one, TCP. Sorry, not TCP, IP version 4. So I'm using the IP version 4. Again, the server address and dot sin underscore port, then which one port I'm using. So let's say you have to type this thing, htons, this, oh sorry, htons, okay, it will, by default whatever you put here, it will take this one as the input argument, and that will be the port defined for the server. So let's say I am using 8080 server. It can be anything, so you can define yours own also. 90215234, so just define it. Okay, and finally I will again, what else do I need? I need server address dot what I need the IP address, right? So I sin underscore a double d r dot s underscore a double d r e, and let me use this one INADDR underscore ANY, which means that assign any address to it. So yeah, it will automatically assign some address to this one, to the server. That's it, I guess. Okay, so now we already defined the server address, and what is the next step to do? Now we have to specify to IP and port, which means we have to bind it. Let's bind uh, the IP and port to the server. Now we have to bind the IP and the port to the server. For that, we will use bind and oops. We will use bind, and inside the bind, what are we binding? We are binding our server socket, this one, right? So server underscore socket, and with what we are binding it, we are binding it with the server address, which is this one, and the server address contains all these informations. So the server address is in the form of structure, right? So I will also specify struct under space, and let me call it sock a double d, or this one. And what is there? There is server underscore address, this one, comma, and the so I should not exceed from this one. I should use of this size, right? So I am good to go. And what is the next step? Listen at the port, right? So I'm done with the socket creation. Then I defined the address, and then I also banded it. Now what is the third one? I have to listen at that particular port. So to listen to it, it's pretty easy. Just use this command, listen, and listen to what? Listen to this thing. Listen to server socket. So I will server yes underscore socket. Okay, and for this is just a very simple program. We are listening to only one client, but there in practice there could be uh, thousands or maybe million of your clients. If you're using a very famous app, then you can have a lot of clients, right, at that time. So you can also put a lot of limit there. For me, I just put here 5. So let me say that 5 I can afford, and then I will say client underscore sock. Let's say I'm using the client socket for this purpose, for what purpose. But before that, I should also say accept the incoming connection from the client, right? So I will say that client underscore sock, and it should save any address except, and except what, except anything coming on the socket underscore server, server underscore socket, and then let me put the other flags null. I don't want anything else. Okay, so anything, any connections coming at the server socket, and the server socket knows this thing, so anything, and then the server socket is also listening, so anything coming from there, it should be the client socket, right? So we will just copy that address here. So the client address is here. Now we have the client address, and since we have the client address, so send the message on the client address. So what is the message? The message is this one: socket programming in C. Once we sense anything coming at the uh, server socket, we will just that will be the client address, and then we will just send the every whatever the message is to that specific address, right? So I hope there is no such thing complicated, and I will just go forward, send, and where to send. I have to send it to the client underscore socket, which we define, which we got here. And what to send? I have to send server underscore message. And how much message I have to send? I have to send the size of the server underscore message. So I should send the entire message, right? So I shouldn't only send one line and then finish it, and then finishing it with 0. And in previous lab we have seen that when you once you create the socket and once you open it, you must have to close the socket, otherwise it will be keep running forever. And even if the client is finished, it is done with the server, it will still keep running, so we have to finish it also, right? So we will server underscore socket, just close the server socket. Oh, sorry, I'm forgetting this semicolons. I should be very careful at this. Okay, that's it. So my this program is created. Sorry, I should save it now. And where to save it? You know it already. It's here, and it's there in the cygwn, then home, then your own username. Inside there you have to save it, right? Why? Okay, so I should simply save it. Okay. Mm, Now I should make a new file, and now I need a client, right? So I'm done with this one. I created the server, I bind it, then I am listening to it, and then I'm accepting it. For client, what do we need? We need to create a socket, and then we need to send a connection request to the server. And once the connection request is received by the server, then it should send, the server should send its own data onto it, and then the client should be able to receive the data coming from the server. So let's do this part now. So again, we have to start from the almost the same header files which we saw earlier. So again, I'll start with those. Include by the way, I have to save it first so that I can see everything, the prediction messages. So that is very helpful. I don't, this will be a client dot client dot c. So stdio dot h, and then what else do I need? I think I should not give any space here, and also here. Yeah, this one is correct. So I'm very used to giving spaces and text. That's why I'm also using it, and it's not good here. And I think also just for safe case, I think R it's fine. I think it's fine here. Yeah. std dot h, and then hash include uh, socket things. So I have to import also the sockets dot h, and then what else do I need again? um, I know it must be boring because you said these things earlier, and if I'm doing it again, it might not be feeling good feelings for you, but it's okay. If you are seeing something again and again, and then uh, maybe I'll not do these things more in detail. I'll be just telling you that, oh, we have seen these things, we have gone through these steps, so you must be familiar with all this stuff. Uh, I'm expecting now that you will be understanding all these steps, and you should not ask that why this thing was happening and why the other thing was not happening. So I hope you will understand everything in future. So for the net family also, uh, inet slash in dot h. Now starting with the main body of the program, and then as conventional method I will just use this thing because I don't want to forget it again. And now I'm good to go. Let's come and see. First I have to create the socket, then I have to connect it, and then I have to receive it. Right, to create a socket it's pretty simple, we already said. So I'll again comment it for your understanding. Create a socket. So to create a socket, it's again pretty simple. int I will call it network socket, so CKT, and now I can use this network socket is equal to SOCKET, and then I can use the AF underscore INET. I should not explain it again, and then I should also not explain this thing again because you know it now, and again I should not explain it. I'm expecting now every one of you know these things, right? So I'm pretty sure all of you can make a socket, right, just with this one line. What is the next thing? Specify the address for the socket. Okay, specify the address for the oops for the socket. So to specify the address for the socket, I'll just simply start with the struct again, and again you know why I'm using the struct. And then server underscore address. So the server underscore address dot, first of all what we need to input here, we have to input the family of the IP address which we are using. So we are using the IP version 4. Then what do I need? I need to specify the port. Oops, I need to specify the port, and the port should be the same as which we specified there. So since we are going to connect with that server, right? So HTONS, and that should be, I think it was 8080. So yeah, 8080. I'm using that port, and then I'm using the server, the address again. So ADDR dot SADDR is equal to INADDR underscore ANY. All right. So we specified the addresses for the circuit, and I think it's pretty okay. I cannot see any error here. But if there is any error, then when we are compiling it, we will see what error is there. Now, um, I have to make a connection, right? So connection request. Let me declare connections. No, no. Should I? Uh, let's move that connect. Uh, so connect what? Connect the network address, network socket, which is this one. Connect my network socket to the specified address, which is this one. So that is in the form of struct UCT. Sorry for my typing is not that fast, so if you feel that my typing is slower, you can just run the video with 2x speed, and hopefully that will be better. It will save you a lot of time. That's what I do when I'm listening to video and I feel that it's going slow. So at that time I move it with twice of the speed, and then it's not wasting that of my time. So you can also do the same. But please make sure you're not skipping anything. If you don't understand it, then you have to uh, play the video with normal speed, or maybe slower speed, but that will be very boring. Okay, so I have to use the network socket, and I have to connect with this address, right? And I should not exceed with from here. Sorry, what I'm doing. Server address. All right, and I should not forget. How about now? Yeah, I was doing right. So IND, let me say connection status, and I should use connection underscore status is equal to this one. Why I'm doing this? I'm doing this if there is nothing received here, if there is no connection established, then this int will have the value of -1. And if it has the value of -1, that means that the connection is not established, and we should double check and make sure that there is no error. That means that there is no connection established at all. And if there is no zero, if it is not zero, then sorry, if it is not -1, then in that case I should use I should proceed. So let me have a check on this one. If connection sorry, connection is this one, underscore status is double equal -1. So if there is any error there, in that case I should say that there is an error in the connection, right? So I should say something like that. There is some error in the connection, and then and let me do 2. Okay, there is some errors in the connection, and if there is no error in the connection, then we should skip this one, and we should keep receiving the data, right? So receive the data from the server. Okay, No, not server. Yeah, maybe from the server. Okay. So RECV. Oh, by the way, when we are receiving the data from the server, we need to have sorry, not integer. We need to have a buffer, right? That was character. So I should say that I have a message buffer, and its length is almost the same. So I should be receiving the. This is my received buffer. So I should be receiving everything here. So receive at the network socket, which is this one, at this network socket which knows this thing, and save it here. Whatever the message coming at the network socket, save it here and the message, and the size should not exceed this one, because we have a limit here, right? We have 256 limit here. I believe it is bytes, but I please you guys make sure it is, when we make it, it is byte or bits. I think it's bytes. So uh, okay, all right. So everything shows is clear. And what is yeah, I need to print it also, right? So I need to print the response. Printf, which is the built-in C command, and I should say the server sends the data is, let's say, what is the data, it should be received here, %s \n, and where is the data located? It is located here in this message. Why? Because we received it in here. That's it. And finally, what is the most important thing? Never ever forget this one, network socket. So we have to close it and then return 0. That's it. I believe I have written everything and I have not skipped anything, I hope. So I'll make sure I save it, right? And let's go and run this. I have to open two windows, one for the server and the other is for the client. Okay, so let me see if my files are still there. Yes, they are. So and I'm in the same directory. By default it will go to the same directory where we have put the files. Now I should compile it. GCC, let's say this one is my server, and I will make an object file and I will call that object file is Salman underscore server, right? You can give it whatever name you like. Oops. uh, uh, these are only warnings, so I hope I don't have error. Don't have error. I hope I'm fine. Okay, and let's do the same thing for this one. GCC, that was server, so this should be the client, right? And I should create Salman underscore CLIN. Oops, what I'm doing, what I did, sorry, I put the enter before Salman underscore CLINT, and I know there are some errors. So what are the errors? Oh, I forgot the semicolon there. Again, I forgot the semicolon there. And that is a very serious problem, serious issue here. And I did something wrong there. So let me go to that file and let me fix the error in the client. Mm, so I didn't put the colon here, And I also don't put the semicolon, not colon, sorry, semicolon here, and I will save it. Yeah, I saved. So let me check if it works now. There are still something connect. Why is there an error? And this one is strap address and server address. It seems fine. Oh, I didn't put underscore here. It should be there. And yeah, I think it should be fine. The spelling must be wrong. Because this underscore AWR. Okay. Oh, I have done something size of in capital. Oh my god, we have done it a key number. Mm. Oh, I see. The problem is. Oh, I see. The problem is here. Now I should be okay. Yeah, I hope it's fine now. Yes, it's fine. It's working now. Now, let's go to the server dot slash server and oops. Oh, no. The name is dot slash Salman underscore server. Allow. I would allow the access. Yes, okay. And dot slash Salman underscore client, not .exe. So here you go. The server sends the data as the socket programming in C. So we were basically printing the server sends the data as and then %s, and that is the message which is coming from the server, right? And what was the server message? The server message was the socket programming in C. So everything is working now. Oh, congratulations. So if you have done the same thing, it means that you created your own socket uh, for the client and also for the server. And then you have to do some minor modifications. I'll also upload some other files and you can do some more practice. I hope it's fine. This is the server which create the sockets, then bind the address to the address and port to it, then keep listening on that port, and finally accept any request coming from the client. And the other one is the client which create a socket and connect to the server, and if there is any data from the server, just receive it, and if you need, you should display it. So that's it. You are now able to create the socket, and that's what I explained you here. You understood what the protocol is, you understood how to create a socket, and then also you understood how the data transmission happened from the server to the client. uh, Again, I think it's not difficult. Just go through this code. I will just upload these two files also, these two, TCP server, TCP client. Now the main thing is, you know, what is the how the binding can be done, how to mm, write the message, how to read the message. So we have already seen those things, and how to close the server. So you should be able to understand everything related to it. And this is the end of today's lecture session for this lab, and I'll see you next in next lab. Take care. Bye bye.